me, Krishna Rao Patro. Today, I'll discuss about one important concept, that is dynamic method dispatch. This concept is part of your polymorphism concept. How dynamically you can transfer the control from parent to child. So the parent can control any child. So here we will see how parent and child, they are coordinating each other. So dynamically the method control has to go. Dynamic method dispatch is a feature in object-oriented programming language. This allows the selection of a method to be executed at runtime. So during runtime, it will choose which method I should execute. Actually, there will be multiple options for the parent. Either it can execute its own method or it can execute its child's method also. So parent having full right to control the child. So for that purpose, the parent having multiple options to run same method name. Method name is same, but parameters, the logic will be different. So the dynamic method dispatch, which allows to select a method during runtime. The mechanism is also known as dynamic dispatch or late binding, or also called runtime polymorphism. So the dynamic method dispatch comes under your runtime polymorphism. I think you know there are two types of polymorphism: static polymorphism and dynamic polymorphism. Static polymorphism we are implementing through function overloading, whereas the dynamic method dispatching or late binding or runtime polymorphism we are implementing through method overriding. So this requires method overriding. Okay. So dynamic method dispatch is closely associated with polymorphism, inheritance in object-oriented programming. So now we'll see how you can implement the dynamic method dispatch. So the main goal of this is what? It allows the parent to choose a particular method during runtime. This allows selection of a method to be executed at runtime, and this provision is given to only parent class. Here there are some key points you can note down. First point is polymorphism. Second is method overriding, because there is no method overriding without polymorphism. First you have to understand how polymorphism implement this concept. Which one? Method, dynamic method dispatch. Dynamic method dispatch is often used in scenario where polymorphism is employed. So without polymorphism, you cannot implement dynamic method dispatch. Polymorphism allows object of different types to be treated as object of common base type. So generally, it is possible with the parent. This promotes the code flexibility and reusability. With the help of this dynamic method dispatch, the code flexibility is better and reusability is also better. So it gives full flexibility as well as it gives full reusability of the code. So that is the main advantage of dynamic method dispatch. Then one more is method overriding. I told you, of course, these two are interlinked. Without method overriding, there is no concept of dynamic method dispatch. In polymorphic scenario, a subclass can provide a specific implementation for a method. So superclass and subclass. Superclass means the parent. Assume A is my superclass, B is my child class. Here I am having a method F. Here also I am having method F. Both method means in both the class you are having the same method. Of course, the logic may be different. But method names are same. But here A is parent, B is child. A is parent, B child. So this parent can invoke either this F or the parent can invoke this F also, because there are two F. Okay. So in polymorphic scenario, a subclass can provide a specific implementation for a method that is already defined in its superclass. Whatever the method you define in the superclass, that one can be utilized by the parent also. So this process is called method overriding. So subclass and superclass will have same method name. Subclass, here A is superclass, B is subclass. Here F is there, here also F is there. In both the cases F is there. So here I may write 2 lines of program, here I may write 10 lines of program. That means the logic will be different. The overridden method in the subclass has the same signature. Signature of the parent as well as child method will be same. Only the number of statements, that logical statements will be different. So name, return type as well as parameters are same in the subclass as well as superclass. Then that is called method overriding. So in method overriding, the signature indicates what? Name, function name, return type, parameters will be same. Then you will see some more important. Actually, there are 4 points. This is the first point. Polymorphism concept is the first one. Second one is method overriding. And third one is runtime binding. That means during runtime it will bind. This method will be executed during runtime. Because a parent's reference can point to anywhere. So, my parent object has to bound to one of the location. That will be decided during runtime. So, that's why the runtime binding. Because in the memory, there will be multiple methods. So, which method I will execute, that will be known during runtime. That will be known during runtime. So, when a method is called on an object, the actual method implementation to be executed is determined at runtime base on the type of object, not the type of reference variable. So, during runtime, it will decide which method I have to execute. This is in contrast compile time binding. Whereas in the compile time binding, the compiler will decide during comparison time itself. In comparison time, you know which one I will execute. Whereas here, during runtime, we will decide where my reference will be jumping, where the method is called to be determined at compile. That is so that means there are 2 types. One is compile time binding, second is runtime binding. Generally, in method overloading, we will use compile time binding. This is method overloading. Method overloading. Where this is method overriding. Method overriding requires runtime binding. Fine. Next, the 4th concept is inheritance. Dynamic method dispatch is closely tied to inheritance. So, when I say dynamic method dispatch, all are linked. What are the 4 things? First is polymorphism concept. Second is method overriding. Next is runtime binding. And 4th one is inheritance. The dynamic method dispatch is closely tied with inheritance because for method overriding, you need inheritance concept. Without inheritance, method overriding not possible. So, a subclass inherits the methods from the superclass. Subclass inherits the methods of superclass. So, these methods can be overridden to provide specific behavior in the context of subclass. So, in parent, whatever methods are there, same method will be available in the child also. Only the thing is, logics will be different. Signature will be same. Please remember. Signature means the name, return type, parameter. If you combine everything, that is called signature. Now, a small program, I will explain how dynamic method dispatch you can use. Assume I am having a class called animal. In animal class, I am having a method called make sound. Assume this method returns one generic animal sound. A simple message I wrote, a generic animal sound. I am having a class called dog. So, my class is called animal. In the animal class, I am having a method called make sound. Make sound. This is a method. Here I am having 2 subclass. What are 2 subclass? One is a dog. Another is cat. Every dog is animal. Similarly, every cat also animal. This is my hierarchical inheritance. Here also having make sound. Here also I am having make sound. Make sound. Here also I am having make sound. So, make sound is available in the parent. Make sound also available in the child. Make sound also available in the child. So, here return type is void. Here also return type void. Here also void. Here no parameter. Here also no parameter. Here also no parameter. So, no parameters. Return type same. Class name, method name same. So, that means it is following the property of our method overriding. But here I wrote generic animal sound. Here I wrote woof. This is the sound of dog. Whereas for cat, I wrote meow. This is the sound of cat. So the statement, the logics are different. So that means what? The behavior of animal is changing. So when I say animal, that is generic one. But when I say cat, that is specific to a particular one. Or when I say dog, that is specific to a particular one. So they are specific to that one. So here it implements what? Method overriding. So whatever the methods are there in the parent, you override in the child. So for dog, superclass is animal. My dog is subclass. Similarly here, cat is subclass, superclass is animal. So here you have implemented the polymorphism concept. You have implemented your method overriding concept, as well as you have implemented dynamic, means dynamic binding or lead binding. So all the concepts are available here. Now dynamically I have to choose whether this sound or that sound. Now let us call a small program to call the reference of these methods. I am having a main method. This is my reference variable. Now animal is my parent class. This is parent. The dog is my child. So animal reference is pointing to dog, because I told you parent can hold letters of child. Parent can hold letters of child. So now when I call my animal dot make sound, now it will give the sound of dog because it is holding dog's reference. Similarly, so it calls dog. So my animal equal to new cat. Here it is holding object of cat. Earlier my animal is object. It was pointing to dog. So that's why it was giving dog sound. Oof. Whereas in the second line, if you observe here, my animal is now referring to cat. When I refer to cat, when I call this make sound, it give means it is jumping to this place. Immediately, earlier it was pointing here. Now it will be cancelling here and it's pointing here now. Now when I say cat dot make sound, it will say meow. So this is the way it works. Fine. So now let us have a small run. How to run this program? We'll go to our notepad. I'll copy this control N. Here you got my animal. This is my generic one. Control N, Control C. Same thing. Let me show. So this is my base class or parent class. Animal is parent, and here dog is my subclass. Similarly, cat also subclass. These four classes are ready. Now I'll write the driver class. The driver class is also available here. Control A, Control C. Now Control V. The class here I'll change the method dynamic method dispatch. Dynamic method dispatch. This is the name. So I'll save this as a Control C, Control S, Control V dot Java. Now let me run. Go to the command prompt. Here how many classes are there? Animal class is there, dog class is there, cat class is there. And what type of polymorphism, what type of inheritance is there? Because one parent, multiple child. That is your hierarchical inheritance. So now let us compile it. Java C dynamic method dispatch. Yes, it is compiled successfully. Now let us run Java dynamic method dispatch. Now when I run, yeah, first sound is coming oof, then is coming meow. That means what? Initially it was holding letters of dog object. Later on it has switched over to cat object. So dynamically my animal reference which is changing its behavior. Of course here you can ask also the user which sound you want. So you can put another way. This is a normal way of calling. you can ask the user system.out.println. Here I can print a message, 1 for dog sound, and 2 for cat sound. Based upon my option, my animal reference would change to cat. Now here I'll ask Control V, 3 for quit. Here I'm making a small menu. Enter the choice. Based on the choice, it has to take. Now let us read the choice using the scan object. Scanner SC equal to new scanner within bracket system.in. So my scanner class is ready. Using the scanner class, I'll read my option. So this requires import util package, import java.util.star. Now here I'll read my choice, int ch equal to sc dot next int. Now based on the choice, now what I'll do this thing, I'll put a loop, do while choice not equal to 4. If it is 4, I'll come out, sorry, not equal to 3. 3 means quit. Now my choice is given. Whatever the choice is there, I should call the respective sound. Now here I'll put switch choice. If choice is 1, my reference should go to 1 means dog. So case 1, go to dog. So my animal reference should go there. Cut, Control C, Control X. Here I'll make this. I'm creating object and calling that one. Fine. Simple. Later on, then break it. Similarly, case 2. For case 2, I'm calling my this sound, cat sound. So during runtime, I will decide which sound I want to generate. So go there. If it is case 3, do nothing because choice 3 means quit. But if at all I give anything, then I'll say default. If default comes means do nothing. But if the choice is 3, come out. So now control is dynamic method dispatch. Control C. I'll come to my command prompt. Compile it. Now there are some errors. System.out.println. Println. This is small mistake. Println. N is missing. Press N. Now based on my choice, now there are 2 more errors. Switch while ch not equal 3. Where the ch is defined? Cannot find the symbol. Now see, ch is here, which is defined. Let me define outside. Control C. So declaration I will not do here. I will do outside the loop. Int ch. Control S. Clear the screen. Next int, the spelling mistakes. So next int, n is extra is there. Compile it. Yeah. Now compile successfully. Run dynamic method dispatch. Now it is asking the option whether you want to switch over to dog or cat. So my animal reference will change. If I say 1, oof. If I say 2, meow. If I say 4, doing nothing, it is asking enter the choice. But if I say 3, or say 1, oof. If I enter 3, 3 means kuch. So it is coming out. Because it was in the loop, until I give 3, it will be running. If I give 1, the animal reference goes to dog object. If I 2, go to cat object. So this is the way dynamic method dispatch occurs. This is a simple example of dynamic method dispatch. And remember, for dynamic method dispatch, you should have idea about polymorphism. In polymorphism again, runtime polymorphism. In runtime polymorphism, you should know your leg binding concept. Because during runtime, it will bind. The animal reference is bound to either dog or cat. That's why it is called leg binding. So please remember, this is the best example for dynamic method dispatch. And here it implemented which concept, which type of inheritance. Animal is my parent, dog and cat are my child. This is hierarchical inheritance. Hierarchical inheritance with polymorphism concept. Okay. Again in the polymorphism, dynamic polymorphism. Okay. Dynamic polymorphism. So this is the way you can solve it. I hope it is clear. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.